everyone, welcome to my second live presentation here. My name is Maliheh Mahdavi Sefat and I'm presenting to you the control flow in Python. This is the final task of step 2 machine learning path CS internship program. Our agenda today is to explain what is control flow, when and how does it happen, see various control flow structures in Python, and to check out some code samples. So what is control flow? It is controlling the flow of runtime execution. Meaning, at any moment during the runtime, the Python interpreter decides which line of code or expression must get executed. It is notable that the interpreter itself cannot directly read our script, but it is the compiler as an intermediary that turns the Python code into bytecode. Then the interpreter can read that bytecode and, depending on the structure it is written in, decide about the control flow. You can imagine a virtual control flow as a virtual cursor moving through the code and pointing out different lines and expressions that must get executed next based on the defined structure. Here are several structures of control flow. In fact, I encountered different categorizations of these structures, though this would be the sum of it. It always starts here with sequential executions, then there are loops, jump statements, exception handling, functions, classes, conditional statement, switch statement, and some extra nested structures to make it really complete. Our first structure is sequential execution. In sequential execution, the statements are executed in order they appear in the code from top to bottom. This is literally the most straightforward structure there is. Here, line n would be executed after line n-1 and before line n+1. The control flow is always sequential unless it has another specific structure. Then there's conditional statements. Conditional statements allow program to make decisions based on certain conditions. These statements evaluate a condition and execute different blocks of code based on whether the condition evaluates to true or false, or like the programmers want to say, truthy or falsy. There's always an if clause that evaluates some condition, and if this condition evaluates to true, this body that is indicated by this indentation would be executed. Then if this condition evaluates to false, control flow jumps over this body, goes to this elif clause, meaning else if, otherwise this condition would be evaluated. If it is true, the body too would be executed. This goes on until we reach the else clause. This means that none of the previous conditions were true. So this final block would be executed if there is a final block and else clause. The next structure is loops. Loops allow the control flow to repeat a block of code multiple times. There are many situations that the programmer needs to repeat some operations and repeat some lines of code. This is the work of loop. The most common types of loop are for and while loops. While loops can provide indefinite or uncounted iteration. For loops can provide definite or counted iteration. These loops continue executing as long as a specified condition is met. This condition could simply be being a member of an iterable. Loops have the potential to iterate over objects that are a member of an iterable. Then there are function calls. Functions are reusable blocks of code that can be called from different parts of the program to do some operations. When a function is called, the program jumps to the function's code, executes it, and then returns to the point where it was called. You see here we have the general structure of a function. We define a function with the keyword def, name it something, and pass some arguments to it to do some operations in the body part and return to us some results. Then anywhere in the program, and we could do it as many times as we want. We call that function and pass some arbitrary arguments to it. Then the control flow jumps to that definition of function, does what it does, and comes back to us with the results. Exception handling are the next structure. Exception handling allows you to handle errors and exceptional situations that may occur during program execution. There are many situations that a programmer predicts a line of code or a block of code might be troublesome, and it may throw traceback errors or some error and halt the program. So they would try to handle that situation with something like this. This includes a try, catch, and finally block to manage exceptions gracefully without any halt. Then there are switch statements. Switch statements provide an alternative way to make decisions based on multiple possible value of a variable. Python doesn't have a switch case on its own, but we can use dictionaries to achieve our goal. They allow you to compare a variable against multiple values and execute different blocks of code based on the matching value. You see here, this is the general scaffolding of switch statements. We have the def keyword, we name the switch statement, we pass values, and inside the body we have a dictionary. We could have some other functions instead of these values, first, second, third. Then the program would jump to that function and do that operation, and it would retrieve the value it gets to us here. Class is another control flow structure. A class is a blueprint for creating objects of certain certain species, defining the properties and behaviors that the created objects or instances will have. A class instance is an individual object created using the class blueprint with its own unique set of data attributes and methods as defined by the class. I don't want to talk about class anymore, but I want you to notice that these properties are actually the attributes of the class instances, and behaviors are methods. We define the class with the class keyword, name it something, and we define some global attributes, and we define some specific attributes for the instances with this init keyword, self.attribute, and we can define some methods for it to be the behavior of that class and does something with the data it gets. And later in the program, when we instantiate an instance of the class, the control flow would come here, finds the class, and defines the instance as it was programmed before. The last but not least important control flow structure are jump statements. Some categorizations would go to jump statement straight after the sequential execution. These statements allow a program to transfer control to a different part of the code, skipping or jumping over certain sections. We saw return before in the function definition, but we have break and also continue, I show you some code examples here to make it more clear. Here I have two simple program. I have several programs, but I have two simple program I named Cupcake and Forecast. I want to show you here. A Python program to simulate a scenario of baking and eating cupcakes at a party. We define a class first, class initialization. See this class keyword cupcake. We defined two attributes of flavor and topping for the cupcakes, and we define a how many method. Sorry, my program always prints a message. It doesn't actually bakes cupcakes for you, sorry. But I numbered the messages to show how the control flow works. You see this message that I defined in the how many is numbered 1. Then there's sequential execution. Welcome statement. There's a statement of to welcome the guests and a print command to print this statement in the capitalized form with title method. You see here when we run the program, it would start here with printing this message. So the control flow comes here to line 14, then line 15. Then we have loops and nested. I should add that the compiler or the interpreter, whichever you like to choose, would completely ignore any commented line or empty line. These commented lines and empty lines are for human eyes only. So the control flow after line 15 comes to line 19. We have a list of flavors here, cupcake flavors, and we want to see a for loop in action. For in Python is actually for each. For each flavor in this list, do something. That something would be printing another message. This is a question. Do you like this flavor? So it would print, do you like vanilla for the first element? Is this flavor strawberry? No. Is this flavor saffron? No. So the control flow jumps over these parts and comes to the else. Print the sixth message, baking this flavor, baking vanilla cupcake. Then it goes back up to the start of the for loop. The next element would be retrieved. Is the flavor strawberry? Yes. This condition evaluates to true, and this body, which is another print, would be executed. The strawberry cupcakes are everyone's favorite. The control flow from here goes back here to for loop and retrieves the next element, saffron. Do you like saffron? This body of the for loop would be executed. Is it strawberry? No. It would be jumped. Is it saffron? Yes. This body, yum, saffron flavor, Persian, would be executed next. It goes on until we run out of elements in this list. Then there's conditional statement. I have a baking time variable here, and I assign 22 to it. I could have asked the user to input whatever number they want, but I would have to go to terminal to run this program. So here I hard-coded 22 here. If baking time is greater than or equal to 30, do this, else do this. Is it greater than 30? No. So it would jump to else. Print this message. Here, printing the cupcakes need more time to bake. Then there are class objects. Do you remember the class we defined here at the start of the program? Class cupcake with two attributes of flavor and topping, and a method of that class. We instantiate two instances of my cake and your cake with this class, and we pass some arguments here, orange, honey drizzle, and we do something with it. Here we just print another message, my choice and your choice. Then we call that method we defined on the cupcake instances your cake dot how many, and we give the number 7. It would use this number here and use these attributes in the formatted message here to print this. You see, the first message we defined would be printed in the middle of runtime. We need 7 saffron cupcakes with sesame seed toppings. Then there are jump statements. We saw the return before. Here we have another list of toppings. For each topping in the list of toppings, if topping is something, do something special for it. So for the first element, ganache, if topping is ganache, is it ganache? Yes, it is ganache. It evaluates to true. Then it continues. What does that mean? It means that the control flow ignores this element and goes back to retrieve another element, goes back to the for loop. It retrieves another. You see here, it doesn't print, it doesn't do anything, and it doesn't jump out of the for loop. It goes back and retrieves the next element, cheese frosting. Is it ganache? No. Is it buttercream? No. Then it goes to the else statement and prints throwing out cheese frosting. Then we go back to the sort of for loop, retrieve buttercream. Is it ganache? No. Is it buttercream? Yes. This statement evaluates to true. Then this message would be printed and the control flow breaks out of the for loop entirely. No matter how many elements is left in the list, they would be left forever. Here we have this message, found the perfect topping, buttercream, and it would break out of the for loop and doesn't go and try another element. Then there are function calls. We have an independent function here. We name it eat cupcake, and we print another message for it. Then anywhere in the program we can call this function with this name we gave, eat cupcake, and give it the instance my cake or your cake or any other instances, and it would use those attributes of the instance, cupcake flavor, cupcake topping, to print another message here, eating orange cupcake with honey drizzle topping. Finally, we have exception handling. If I ask the user to enter some inputs and give me the name of guest they want, they may had entered a negative number, but we wouldn't want a negative number here. So we try to handle this situation of entering negative number with an exception handling structure. If the number of guests is less than 0, meaning negative, raise an arbitrary error that we define here, an error of value error kind. And we have the exception part here, exception value error as VE. The control flow comes here. Here you see the message number 15. Invalid input goes and retrieves that message as the VE and prints that, and the control flow would jump over the else because before that it executed the except part, jumps over the else, and the finally block would always be executed. Bon appetit. And we don't have much time to explain this another program. Here we have another program to forecast weather. You see, we have all these structures. Thank you everyone for coming to my presentation and kindly watching my presentation with all of these problems. Thank you. Have a nice time.